attend, this talk instead of this one and this one, but I do question your judgment. With that being said, we're going to spend the next 30 minutes or so talking about quite a lot of stuff. It's serverless, it's AWS, it's TypeScript. I've run out of, buzzwords to put in the title. And we're going to learn how do we combine all those technologies together to build a compute platform, which allows us to execute arbitrary customer-provided code in our system. But first, some motivation. Imagine that you started using a brand new, shiny tech product. It's like a software as a service application or something like that. And you are quite excited about this because it seems to solve all your problems. And you see, yes, this is exactly what my startup needed. And after quite some time, you realize that, yes, you can do everything apart from this one very specific thing. And it's always like this. Every single time you adopt a new tool, you find out that, yeah, oh crap, if only it supported this one missing feature that I really want. But you might be thinking that, hey, I am a developer, right? So how hard can it be to just, implement it myself, right? I know some basic CSS. Like, how hard can it be to, for instance, add an edit button to Twitter? It's like, 3 story points at most. But on a more serious note, the problems that I'm involved in on a day-to-day basis nowadays relate to more of a system integration kind of stuff. So suppose you have 2 different software systems that you would like to integrate with one another. And you have to build something that is going to live between those. And those kind of integrations tend to have quite a lot of extensions and adapters and connections, and it gets rather messy. And even though you try very hard, you won't be able to support every single potential business use case of your customers. This is why we have decided to try something else. At Steady, we have built a functions product. So functions allows us to so that our customers are able to write their own business custom logic and execute that in our system. Doesn't sound exciting? Well, because it is. Doesn't sound incredibly scary from security perspective? Also, because it is. My name is Tomasz Lakomy. I am a front-end engineer at Steady. I've been also teaching web development at eke.io for the last 3 years or so. And last year, I was named an AWS community hero. And Steady is a fully distributed startup. We have employees all around the globe. And I'm especially excited to be a part of my favorite team in the entire company, which includes Maciej Winicki, Rafał Wiliński, the owner of Dynabase, Wojciech Matuszewski, who is the nicest person on the planet, and myself. And all of us are based in the same city in Poland, which is Poznań. So this is great. We get to combine, being fully distributed and also having friends in the same city. As for Steady, we are building a developer-focused platform for building EDI solutions so that customers can integrate with any business system. And for the record, you are not expected to know what EDI is, and I promise this is relevant for the talk. So EDI is essentially the backbone of modern commerce, which you have never heard of, probably. EDI stands for Electronic Data Interchange, and it is a data communication standard which has existed since the early 70s. It's like 20 years older than I am. And the reason why it's so important is that every single time you buy something online, so for instance from Amazon, you can be absolutely sure that there's lots and lots of different EDI transactions being sent all over the web. On top of that, an EDI transaction looks like this. And I promise this is not a random string of characters. This is something that actually happens like underneath the hood of the entire commerce industry, but this is not limited to commerce. On top of that, if you have like 2 businesses like Pepsi and Coca-Cola, they want to do business with one another. Everybody is going to have a different way of thinking about this file format because there's like gazillion different versions of it. And it's incredibly hard to integrate 2 different trading partners. In fact, it can sometimes take a quarter or a couple of quarters using traditional approaches, which is why, again, we have decided that we cannot support every single potential business use case. Instead, we're going to allow customers, hey, write your own very custom business logic in TypeScript, and then you can execute a function that you provide to us with an arbitrary input. So let us gather some requirements first. First of all, customers should be able to execute arbitrary JavaScript and TypeScript code with an arbitrary input. Neither of those that we do control. which of course means that it has to be executed in a secure, controlled way. Like we definitely do not want to be hacked. On top of that, we would like to utilize managed services for us to focus on writing the business logic and not, maintaining actual servers. And that is why, like in my opinion and in the opinion of growing number of people in the developer community, building on top of AWS and serverless is, well, it's quite convincing in 21st century. And I was preparing the slides for this talk, but then I figured that I could just outsource it. So I asked the people of Twitter, what is the biggest benefit of going with serverless technologies in your opinion? And the first answer I really liked was this one, that the major benefit of going serverless is being here on stage and talking about serverless, which I have to admit is quite a major perk. I also like this one, which is mandatory. You have to say that with serverless, there are less servers. Yes, that is absolutely true. There are less servers that you have to care about on a day-to-day basis. On a more serious note, this is excellent. That with serverless, we, the companies and developers and startups, we get to spend our time solving business problems. And the cloud provider gets to worry about all the fun stuff, like elasticity, redundancy, DNS, hardware maintenance, security patches, building a data center, hiring people for data center, and many, many, many more. In short, building on top of AWS is like hiring a world-class engineering team to build features for you, including post-quantum TLS. I swear I'm not making this up. You probably don't need something like this. I have no idea what this is. But the thing is that if you happen to have a business case for, again, post-quantum TLS, it's there. You can start using it. You don't have to build it yourself. And you get to focus on solving the business problems. OK, so we want to write only code for solving the actual problems that we have. We have to choose a tech stack. And usually you tend to choose 3 languages, more or less, for a full-stack project. It's front-end, back-end, and something to provision infrastructure. So front-end is usually JavaScript, back-end is PHP 2.0, and infrastructure is a bunch of random scripts that a sysadmin wrote in 1975, and nobody remembers how to run them anymore. And it's always like this. Well, luckily, in the year of 2021, we get to use a single programming language for all 3 of those things, and that is, of course, Scratch. Sorry, not this one. This one. But for the record, Scratch is the best thing that has ever happened to the no-code, low-code movement. It's absolutely an excellent way to teach people how to program. But I'm talking about TypeScript here. TypeScript has grown to be a remarkably powerful language over the years. So front-end, yeah, sure, because it is JavaScript in a trench coat. Backend, yes, definitely. Node.js or Deno supports, for instance, TypeScript by default. But what about this infrastructure bit? Because the first time I heard you could do infrastructure with TypeScript, I was like, really? Yes, really. There's AWS Cloud Development Kit. And the best way I've heard it explained is basically CDK is like React for AWS. Whenever you use a React component, you tend to do a thing that you render a component, and then you update its state. And you don't notice how you definitely don't think about how exactly this component is going to be rendered in the DOM, how exactly this component is going to be updated. You just want it to be updated. Same with CDK, where you get to write code to say, hey, by the way, I would like to get a DynamoDB table in my account with this billing mode, this partition key, and this sort key. And just make it happen. Because this is like a very declarative way of thinking about your resources in the cloud. And notice that this is code, which sounds obvious, but that means that you get to do code reviews. You get to store it in version control, and you get to also write tests in order to assert that you are putting the required resources in the cloud and connecting them in a proper way. On top of that, for instance, another example is that you can also do Lambda functions with CDK. In fact, you can do basically all resources that are provided by AWS using CDK. So in this case, the only thing that we need is to provide the entry file. So the actual code that is going to be executed whenever this Lambda function gets triggered. And there's also a bunch of different props, like a timeout, you can set it, and environments. So for instance, break in prod, like please don't. Like we don't want things to break in production. But the last line here, this is something that I consider to be crucial, is what it says is, hey, by the way, this function should be able to read the data from this DynamoDB table. I don't care how you do it, just do it. And you don't have to be like an expert in cloud permissions and identity access management in order to get this working. This is extremely, extremely powerful. On top of that, in order to bring this comparison between React and CDK closer, in React, you tend to create a component that renders another component, that renders another component, and so on and so forth. With CDK, you can do exactly the same. In fact, you can build your own custom constructs that include a bunch of AWS resources connected in a certain way. So for instance, imagine that in your company you have a common infrastructure problem to solve. I don't know, setting up a REST API with AWS. So what you can do is that one team can write a construct, like baking all the best practices into this construct, publish it on NPM, and the entire team can do just npm install our REST API, hit enter, hit deploy. Simple as that. OK, now we know how we want to deploy stuff, but what do we deploy? And every single time you talk about serverless architectures on stage, you have to show something like this. And this is a meme that I have totally stolen from Swix. Thank you for sharing that. It doesn't have to be like this. Luckily, in our case, it was much, much simpler. There are two basic flows for building a system like this. First of all, we would like to be able to create a function to be executed later. Right? So our customer is going to come to us, give us a function name, so hello world, and the code of a function. They're going to call an API endpoint. We're going to trigger a Lambda function that is going to store some data in DynamoDB about this function, and also is going to dump the function code in S3. Well, we have to use S3 for storage because DynamoDB has a limit of 400 kilobytes per row, and this is JavaScript, so probably everyone is going to install half of the internet, put it in Node modules, so it's like 10 gigabytes or whatever. I'm joking, of course, but use S3 for storage. This is what it's designed for. Notice how there isn't anything particularly dangerous here, because code is harmless unless, of course, you invoke it. So this is how we invoke a function in our system. Customer comes to us, they have a function ID and a JSON event that they want to execute this function with. So basically, it becomes an argument to this function. And this is going to trigger our invoke Lambda function, which is going to get the data from DynamoDB that was stored earlier, and it's going to get also the functional code from S3. And it's going to take all of this and send it to a runtime function, which is in the upper right corner of the slide, which is in a separate AWS account. And this is crucial, because you have to be secure. So first of all, there's a separate AWS account, which only has a single Lambda function inside of it. There's literally nothing else in this account. On top of that, the only thing that this function can do is execute its code and write logs to CloudWatch. And that's it. Why? Because security is important. And you might be thinking that, yeah, but I'm building on top of a cloud provider. I'm paying my AWS bills, so why do I care about security? Well, with AWS, you have a shared responsibility model. So the idea is that you are responsible for security in the cloud, whereas AWS is responsible for security of the cloud. So for instance, AWS is responsible for the bunch of things, which you can see on the bottom half of the slide, including like the physical security of your hardware. That nobody is going to go to your server and just pull it out, because then it becomes serverless. But you are responsible for the security of things that you put in the cloud. So resources, how do you configure resources? How do you do identity and access management? This is not simple, but it is so much worth it, because remember that people are incredibly clever. Everything that can be broken will probably be broken at some point. As a reference, I watched this talk the other day about how Ian Coldwater and Chad Rickansrud, they've managed to break out of a Docker container on a mainframe. And granted, I don't know very much about either of those topics, but I do know that it was considered to be impossible for the longest time. And it's always like this. Something is impossible, then somebody goes in and actually does this. So remember, you have to be quite careful when you are handling arbitrary code. Because every single time you build a system, any software system, you have to think, what is the worst thing that could possibly happen to it? Is it this? Well, this is not fun. Having your website being broken in production. Quick show of hands. How many people have done this? OK, all of you, because half of you are lying. With that being said, this is not the worst thing that can possibly happen to your system. The worst thing is this, the loss of trust. Because, well, a website being down for half an hour is not pretty, but if you start leaking customer data, or if Pepsi is able to see the arguments to a function that Coca-Cola used, it's not going to be pretty. It's going to be quite damaging to your business. But let's get technical. How do we actually execute this stuff? Let's get down to the code level. We have code, and we want to execute it and avoid going bankrupt. Well, do we do this? Sorry. Do we do this? Absolutely not. This is the best way to get fired, because evil is evil. Don't use it. We are using something a bit more sophisticated, which is VM2. VM2 is a secure sandbox for running untrusted code in Node.js. So the idea is that you get to create a secure sandbox, and you're going to get your code, put it in a sandbox, and say, hey, you can only play with this, I don't know, red bucket and this blue shovel. This is the only thing that you get, nothing else and nothing more. So this is how we create a sandbox. So for instance, you can specify inside of the sandbox that, hey, whatever we put inside cannot use evil, because evil is evil. They cannot use WebAssembly, because we want to only support JavaScript and TypeScript and not necessarily WebAssembly. We're going to specify a timeout. More on that later. And we're going to also tell them that, hey, by the way, you can only use URL, query string, and of course, jQuery inside of it, which is, of course, totally a Node.js built-in module. And this is going to create a secure sandbox. And this is how you execute code in that sandbox. So you're going to get the sandbox and run the run function, passing in the code that is meant to be executed. That is going to create an instance of a function, which can then to be executed with an input provided by a customer. Because the only thing that this function can require is this list on the bottom here, and nothing else can be required. So you get to control what exactly, what kind of fun stuff a customer can do inside of your system. But we've noticed some kind of problems with this approach. First of all, in some cases, it was possible for a customer-provided code to completely block out the event loop. And this is not something that we wanted, of course, because then our entire Lambda function would time out, and then I would get PagerDuty alerts. This is not something that I wanted. Secondly, notice how on this graph, there's a single runtime account in the upper right corner and a single Lambda function. And that is shared between customers. So like Pepsi and Coca-Cola are going to use the same Lambda function. Usually, this is not a problem. And in fact, it happens all the time when you're using cloud providers. But here, given the fact that we don't control the actual code that is going to be executed, we have to be extra careful. So we have started using something called Threads.js, which is an open source project on GitHub, which allows you to, among many other things, to use worker threads in Node.js. Worker threads are a relatively new feature in Node, and this is an example that I borrowed from the documentation, where you get to upload CPU-intensive stuff, like, I don't know, mining Bitcoin, to a separate worker thread, which means that your entire event loop will not be blocked whenever something very CPU-intensive is going to happen in your Node.js code. You can think of it as web workers for Node, and you'll be not very far off. But what was important for us here is that every single worker thread creates its own separate realm. In short, whatever happens inside of a worker thread stays inside of a worker thread. So there's no potential for Coca-Cola executing their function, leaving like a global variable behind, and then Pepsi being able to read that. This won't be a case because we clean up after ourselves. So this is basically how you used it. And another issue that we get to solve with this kind of approach is we are giving the worker only a specified amount of time to work. So this worker is going to spin up this secure sandbox inside of it, and we're going to, as harsh as it sounds, we're going to kill the worker, don't quote me, after specified timeout. So like 3 seconds, 5 seconds, which means that if somebody is going to do something funky inside of this function, we're going to terminate this function anyways after a specified timeout, which also makes sure that nothing is going to get left behind, and we won't have any timeouts. So to recap, we have this, we have the architecture, we have threads, and we have VM2. So in order for someone who would be incredibly clever to do actual kind of damage to our system, so for instance, to be able to read the data from this DynamoDB table, they would have to write some very specific code that would escape a VM2 sandbox, that would escape a worker thread, that would escape the entire freaking Lambda security model, which I don't have the time to cover, but I strongly recommend watching this at home. This deep dive into AWS Lambda security talk from last year's reInvent is absolutely excellent, and it goes into so much detail into how they make Lambda secure. I do strongly recommend that. And afterwards, after they manage to break out of the entire Lambda security model, they will have to cross AWS account boundaries. In our opinion, this is more than enough to make this system secure. But on top of that, given the fact that we are getting the customer-provided code, we get to do some stuff with it. So for instance, we can help our customers write better code because, well, for instance, we require a default export to be in the function file because otherwise we won't be able to execute it. So we are running ESLint on top of customer-provided code. And that is a great approach. Whenever you build something that is user input driven, help them. Building stuff on the web when you have like a blank page and you are supposed to type stuff in, it's not simple, regardless if it's code or documentation or anything like that. Make sure to help your customers. By the way, notice this is how we display those ESLint errors in our UI, and we have built a function editor in the browser. So let's talk about front-end. I am a front-end engineer, and I've spent the last 20 minutes talking about everything that was not front-end. But we have this API, we have the architecture, we are able to call the function, it's going to be secure, but this is 2021. I want to be able to log into a website, navigate to the UI, and just run some code in the browser, hit save, hit invoke, and get it running. So we are thinking about this, and we figured, OK, let's build our own code editor together. Luckily, it fits on a single slide. There we go. It's a text area, and that's it. Well, there's this idea of a minimal effective dose, where you take a problem and you start to think about what is the minimal amount of things that I can do in order to effectively solve this problem. Is it minimal? Sure it is. Is it effective? Absolutely freaking not. Because apparently, building a code editor is incredibly, incredibly difficult. We didn't have to do this. There's this thing that is called a Monaco Editor. If you didn't know, I didn't, for the record. Sorry. Monaco Editor is the code editor that powers VS Code. This code editor that all of us love, or at least tolerate? It's being powered by this Monaco Editor, which is completely open source. And it is incredibly powerful and easy to get started with. On the left-hand side here, you have the example from their documentation. So this is how you create a function editor. You run the create function, pass in some DOM node, and pass in some default props, like setting up the default language, JavaScript, and some default value. And on the right-hand side, you can see a fully functional code editor in a browser. Imagine building this 10 years ago with jQuery. I would argue it would be probably a bit more difficult. On top of that, this is like 10% of possible props and options that Monaco Editor takes. Honestly, this is incredibly, insanely powerful. And I would even argue that if you have a use case for code editor in a browser and something cannot be done using Monaco Editor, I would argue that it is freaking impossible. For instance, I would like to show you an example of something more kind of advanced that we did with it. So you can teach, in a way, this Monaco Editor how to play with a custom syntax that it has never seen before. So for instance, in another part of our system, we are using a JSON query manipulation language, which is called JSONata. The language itself is not the point, but the point is that Monaco does not support this. But it is possible to teach this Monaco editor, hey, by the way, this is how you do syntax highlighting in this editor. This is how you do autocomplete for this particular language. It's not exactly pretty, because to do syntax highlighting, you have to do regular expressions, and it's not simple. It's not exactly pretty, but it is entirely doable and extremely powerful. Speaking of things that are pretty, let's talk about Prettier. I am a huge, huge fan of Prettier. First of all, because it eliminated all those, code review discussions, as in if you have to use a semicolon there or here, if you put a comma here. No, I just hit Command S, and the code is formatted for me. And we figured that, how about we give that to our customers as well? Why? Because this is something that people are not talking about enough when it comes to Prettier. Prettier is a syntax validation tool. Because notice when you are writing code and you hit Command S and it doesn't shift because Prettier is not unable to format it, then you know that you screwed something up. You have a missing comma or something like that. So we figured that, hey, how about whenever users tries to save a function in our editor, if the Prettier, like this function, will not be able to execute, we won't save that. Because what is the benefit of saving stuff that won't be invoked anyway? And again, this is something that I do highly, highly recommend. If you have anything that is user input driven, help them. Do whatever you can in order to help your customers, your users, use your software, and they will be very much grateful for you to that. I would like to leave you with a bunch of takeaways from this talk, because I do understand that it was a lot. So first of all, consider building with TypeScript. I am not telling you that the TypeScript is the best possible programming language, because probably it's not. Is it the best programming language for a business? I have no idea. But what I can say that being able to use the same programming language in front-end, back-end, infrastructure all across the stack has been incredibly powerful for us. The fact that I can fix something in the front end, then dive into our infrastructure code and dive into backend afterwards without having to switch gears in my mind between JavaScript and Python and PHP, this is outstanding. And the fact that we get to share tools and practices, we get to share types between front end and backend, this is great. I do highly recommend consider building with TypeScript. Secondly, building on top of serverless technologies, thank you. It means that you get to build in a matter of weeks, not years, because all those things, if you use managed services, most things tend to get so much quicker. Provisioning a production stack is not a quarter of work, thank you, but it's a couple of minutes. Hit npm deploy, and there you go, we have a stack deployed. Related to that, stand on the shoulders of giants. And this is not only about serverless and cloud, but it's also, in this case, this Monaco Editor. We could spend, 5 years building a code editor, or we could just realize that this is a giant problem, take this giant Monaco Editor that was already implemented and stand on its shoulders. And this worked out perfectly for us. And again, this is something that I do highly recommend. And lastly, and perhaps this is the most important bit, test your assumptions. Whenever you are building something that a customer who's clever could break, do not assume that, hey, they will never do this. They will never do that. Nobody is going to, copy and paste 10 gigabytes into a code editor. Because they will, or at least someone will, or your coworker will, because they will be curious whether it's going to explode or not. Remember, people are incredibly, incredibly clever. With that being said, I wanted to thank you, all of you, for attending this talk. Thank you.